This is R.D. Sharma Solution Class 12, Chapter 9 Continuity. Exercise is 9.2. Discuss the continuity of the function fx. There are two functions actually, and when x is less than 2, that is on the left hand side, the function to be employed or suggested is 2x minus 1. And on the right hand side, that is x equal to or greater than 2, the function is 3x by 2. So we have to discuss this continuity. Okay. So there is a point where some inversion is there. That is, the function is inverting, so function is changing. So that particular point is continuous or not. So this 2x minus 1, it is a polynomial function. And polynomial function, we know already about it, that it is continuous everywhere. Coming to on the right hand side, that is 3x by 2. Now this is p by q form. P is 3x. So since p, this is also a polynomial function, and 2, which is a constant number, if this is also constant, is also a continuity, it follows. So the function 3x and 2 are continuous because polynomial constant function, right? So the quotient function, that is the p by q form, this will also be continuous when x is greater than 2. So we have to see the point of contention, which is x equals 2, where actually these two functions meet or change. So we will just go a step back and step forward, that is 2 minus h, 2 plus h. H is very small, and we call it as the left hand limit and right hand limit. Okay. So left hand limit and right hand limit. What are the values? Because on the left hand side, we have to use another function. Excuse me. On right hand side, we'll use another function. So x is 2 minus h, x equals 2 plus h. So first function is 2x minus 1. So x is 2 minus h, we'll put here. So it will be 2 into 2, 4 minus 2h minus 1. Apply the limit. H tends to 0. So it will be 4 minus 1, that is 3. Right hand side, 2 plus h is there. And we are going to put it in 3x divided by 2. So 3 multiplied by 2 plus h divided by 2. This is going to be 6 plus 3h and divided by 2. So apply the limit here. Limit h tends to 0. 3h is 0. 6 by 2 is 3. So what it suggests is the left hand limit and the right hand limit, they are equal. So continuity is there. We have to add one more thing here. That the value of the function at 2. What is the value of the function at 2? So this f2 is going to be 3 multiplied by 2 divided by 2. That is, put the value of x equals 2 in 3x by 2. That is the value of the function at x equals 2. So it is going to be 3 again. So left hand limit, right hand limit, and the value of the function at 2, they are equal. So fx is continuous at x equals 2. Discuss the continuity of function fx, which is equal to sine of mod x. This is a modulus function inside. So this sine mod x, there are two things here. Because the modulus of x is by itself a function. Modulus of x, we already talked about the continuity, differentiability, etc. of this mod x. And the sine theta, sine x, this is another function. So there are two functions here. That is, mod x is a function which is inside sine x. In place of x, we have put in mod x. So hx, if you assume it to be modulus of x, this h, and assume this mod x to be theta. So sine theta is by itself a function. So hx, just assume that mod x is hx and gx is sine x. So in place of x, there is mod x. So sine of x is sine of mod x basically. So sine of mod x, you can represent it, that is hx is placed inside x. So g of hx it is. So gx is sine, this mod x is what? This is hx. If we take it as a function of as hx, so gx is sine of hx. So what does it mean? That means in place of x you might have put hx, which is actually a function. So g of hx is sine of hx. Then this is the only way when the sine hx will come. I'm just trying to tell you that there are two functions, combination of two functions, or you can say operation of two functions, which is g operation hx, because g operation h of x is g of hx. G of hx. So this is nothing but operation. You might have heard about GAW, fog, like that. So you can assume this one is g, one is f. Here I have taken it as h. You can always take it as f. So this is an operation, GAW operation, fog operation. So now we know the continuity, that for a GAW or a fog, for two functions, if they are continuous, then the fog and GAW function will also be continuous. That is, the real number is a big boundary or the values. So if you take some C point, say, in this domain, the domain of real numbers, then if f is continuous at C, what does it mean? The value of the function at C should be fc. The value of the function, that is sine mod x, if you put sine mod c, it should be equal to fc, that is sine of mod c, which is understood also. Okay. So let me tell you again about this gx and hx. Gx is if you take it as sine x, hx if you take it as mod x. So this function which is given to us is nothing but g operation h, GAW h. So g operation h of x, it is g of hx is what? G of hx means the function of g, the value of x has to be replaced by hx, which is mod x here. So g of mod x, and what is the function gx, which is sine x. So this mod x I have to put in gx, so sine mod x, right? So this sine mod x is what? Fx. So when we started with the value of the function at x tends to c, we have got fx. We have got fc if you replace it by c. So this is the operation one. Okay. So when two functions are there, they are individually continuous. The operation of these two functions, which is GAW, fog, or what kind of operation, division, multiplication, all these will give you the continuity. So this is continuous, sine mod x is continuous for all values of real number. Okay. Mod x, sine mod x are, sine x are individually continuous. So the operation GOH, hx, we proved it to be g of operation hx. Okay. So when we prove that this is actually an operation and there are two different functions, this is whole is continuous. Prove that fx equals sin x by x when x is less than 0. This is x is less than 0. We are going to use sin x by x. X is greater than or equal to 0. We'll take it as x plus 1. Okay. So this is continuous everywhere. The first thing is individual functions we have to see. First is sin x. And it is divided by x. So this is p by q form, quotient function it is. Now we have just discussed that sin x is continuous everywhere. Sin x, this is divided by x, which is an identity function. So x is an identity function, sin x is a trigonometric function. They both are individually continuous everywhere. So the division, that is the quotient function sin x by x, this also is continuous at each x. Okay. X plus 1 is again a polynomial function. So this is also continuous everywhere. We have to see the point of contention is x equals 0. So we have to go a step back, step forward, which is the left hand limit and right hand limit. So x is 0, so we'll just subtract some value 0 minus h. We'll add some value which is h, which is 0 plus h on the right hand side. So left hand side and right hand side we are trying to find out. X will be replaced by 0 minus h in left hand limit. X will be replaced by 0 plus h on the right hand limit. But when we go to the left, the function employed will be sin x by x. On the left hand side, it will be sin 0 minus h by 0 minus h. And please assume that I am putting that limit h tends to 0. See, why I actually show you the solution, because I can have solution in my hand and I can always tell you how to solve it. But the thing of the reason of showing you the solution is that how you are going to write it. Logic I am going to tell you, reasoning I am going to tell you, but the main thing is what you have to write, like given, let us consider, also, and the limit properly writing, brackets properly using. Okay. Now coming to the right hand side, right hand limit, I am placing 0 plus h in x plus 1. So the left hand becomes 0 sin minus h by minus h. You know that sin minus theta is a minus sin theta. So this is going to be minus sin h divided by minus h, negative negative cancel, sin theta by theta, limit theta tends to 0, or sin h by h, limit theta tends to 0 or h tends to 0 is going to be 1. This we know. Now here h is 0, 0 plus 1 is 1. So both ways, that is left hand limit, right hand limit, the values are same, which is equal to 1. Right? So when left hand limit and right hand limit are equal, the function is continuous at x equals 0. Now what is the value of the function at 0? Since we have x greater than equal to 0, we have to use this function, because for equality, when x is equal to 0, we have to use x plus 1. So I am replacing this x by 0, so 0 plus 1 is 1. So left hand limit, right hand limit, along with the value of the function at x equals 0 is 1. So we can say that fx is continuous everywhere, right? It is continuous everywhere. Show that the function gx equals x minus, and this is GIF, greatest integer function. So I'll call it as GIF. So this is continuous at all integral points. We have to show it is discontinuous. This you can say square bracket of x is GIF, greatest integer function. Now there is a property of greatest integer function. First of all, integral points 0, 1, 2, minus 1, minus 2, because the question is talking about the integral points, not the real number, only 1, 2, 3 or minus 1, minus 2, minus 3, right? There is no other function, there is no other value being put. Now greatest integer function, if we just take it as say n, and let me explain it with an example that will be more better. Because the greatest integer function, for example, you take 2 and 3, these are two integers, and there will be certain values inside, actually infinite values. So we have 2.1, 2.2, 2.9, 2.96, 2.9996, like this. There are indefinite value which can be between 2 and 3. But for 2.2, the greatest integer function GIF will be 2. For 2.9, it is going to be 2. So greatest integer function is actually a floor function, you can call. You'll always take the lower integer until it becomes this next integer. You got the idea? So here we have gx equals x minus of GIF. And this greatest integer function I explained you. First of all, this function is defined in this integral point, because you're not getting any 0 by 0, infinite by infinite, 0 by infinite, or infinite by 0, any kind of this operation or the formulation you didn't get. That means it is defined. So if you take say 1 minus greatest integer function, or GIF of 1 is 1 only. So 1 minus 1 is 0. Okay. Now we have to, this value of the function at some n we have already found out, it is 0. But for n equals z or n belonging to z integers, we'll take the left hand limit and right hand limit. And in the left hand limit and right hand limit, we would like to find out whether they are equal or not, or whether they are equal to 0 or not. Because gx at the value of n proper or x, we have just found out. Gn equals n minus this gif of n. Okay, the left hand limit and right hand limit. So first value, as I said, if you don't change the value or the value of the function at some certain integral value, it is going to be 0, because I showed you 1 minus 1 0, n minus n 0. Now when coming to the left hand side, we have to subtract some h from n, and on the right hand side we have to add some h to n. So the left hand limit and right hand limit, LHL and RHL. See, g in place of x, we are putting g n minus h. So we can call it as x tends to n plus or x tends to h tends to 0, both ways. So g n minus h, in place of x we have to replace n minus h, because we are taking the left hand limit. So we have subtracted some h from n. So both time you are going to replace n minus h, n minus h. Now I told you that when you have something less than n, you have to go to the floor of that value. Say for example n minus h, it would have been 3. So when you subtract some 0.01 value, it will be 2 point something, and you have to take 2. That is n minus h, you have to take value as n minus 1, the floor. Okay. Now apply the limit, n minus h minus n minus 1. So h tends to 0, this is going to be 0, n minus n plus 1 it will be, and n gets cancelled, you have 1 here. The value is 1. Right hand limit, let us come on to the right hand limit. What is the right hand limit? X equals n plus h. In place of x, replace it by n plus h. So you have limit x tends to n plus, you can write, limit h tends to 0, you can write, it's up to you. Okay. So this is n minus or x minus gif of x. I'll replace x by n plus h. So n plus h minus n plus h. Now you are moving forward from n. For example, it is 3. So you are adding something to 3. So it will be say 3.001 or 3.1 or something. But whenever you get this value, you have to take the floor. So you have to take 3. So for n plus h, you will always take n only. For n minus h, we have taken n minus 1. For n plus h, you will always take n, which is the floor of value. So n plus h minus n it will be, and n gets cancelled, h is 0. So when you apply a limit h tends to 0, it is going to be 0. The left hand limit is 1, right hand limit is 0. The value of the function at some value n is going to be 0. So these three values doesn't match, two values match. But before going to the value of the function at n, the left hand limit and right hand limit by itself, they are not equal. And when they are not equal, you can say that this function is discontinuous. Continuity and discontinuity, the basic step is LHL has to be equal to RHL, which is not the case here. Okay, this question we are going to take in the next discussion. Till then, thank you so much. Take care of yourself.